Okay, moving on to hypothesis tests for the slope coefficient of the regression model. We can also construct confidence intervals for the slope coefficient as well. So there's three ways to conduct the test. One is a two-sided test where we test the slope coefficient beta 1 is equal to 0 versus it does not equal 0. We can also conduct a one-sided test where the slope coefficient is greater than 0 for the alternative hypothesis or less than 0 for the alternative hypothesis. The most common is the two-sided test. It is typically what is given on the computer output for different software packages, and we'll look at that in the next video. Okay, the test statistic is calculated with the estimate for the slope coefficient in the numerator. That's just b subscript 1. And then the denominator is our standard error of the estimate divided by the square root of the sum of the squares for the x. And this denominator is called the standard error. And it's the standard error for the slope coefficient. Okay, and so you might be wondering, what do we use for the degrees of freedom? The degrees of freedom, instead of just n minus 1, like we've been used to using, for regression, it's n minus k minus 1. Another way to write it too, you might see it in the text, is n subtract k plus 1. They are equal to each other when you remove the brackets. Okay, k in this case is equal to the number of explanatory variables or predictor variables in the model. So in our case, for this simple linear regression, there's always one explanatory variable, and then we subtract 1, so that ends up being n minus 2. So it's always degrees of freedom, n minus 2 for these tests, and also for the confidence interval. When we get into multiple regression analysis, you just simply need to remember the formula, and you just take the size of the sample n and subtract the number of predictor variables or explanatory variables, and then subtract 1. Okay, so for simple linear regression, it is always n minus 2 degrees of freedom. All right, for our example that we've been working through, we can test then the null hypothesis that the slope coefficient equals 0 versus, let's do this two-sided, because most of the time that is what we want to know. If it does not equal 0, and we can put in our values that we had, that we calculated previously, was 0.519 for the estimate of the slope coefficient. And then in the denominator, we calculated 4.38 for the standard error of the estimate. And for the sum of the squares for the x's, for the x, we have 4480. So we take the square root of that. That ends up being 0.519 divided by 0.06544. I'm doing it separately because you may be asked what is the standard error for the slope coefficient, and if you are asked that, you simply enter in for your answer 0.06544, because that is the standard error. We plug all that into our calculator and we get 7.93. Okay, we can then estimate with the t table. So we have to remember our observed t was 7.93, and we want to see where that would fall. So we have 5 customers. Our degrees of freedom is going to be 5 customers subtract 2. So that's going to be 3 degrees of freedom. That's this row here. And we see that 7.93 would fall somewhere between those two. And because it's a two-sided test, we would take 0.001 and multiply it by 2. And so the range is going to be from there 0.005 and multiply it by 2. So I'm taking these values, we multiply it by 2 because we want to know the area under the curves for both tails, right? We want to know, because it's a two-sided test, we want to know the area under the curve for each side. All right, and that ends up equaling 0.002 to 0.005 times 2 is going to give us 0.01. And that is our range for our p-value, our two-sided test p-value. And because that value is so small, we would then reject the null hypothesis and accept then that we would accept this, that the slope coefficient is different from 0. What that means then is that the predictor x, which was in this case time spent, right? We were using time spent to predict the online sales. We can say that there is a statistical, it is statistically significantly associated with the online sales because we rejected the null hypothesis. So that means that the predictor variable x is statistically significant in predicting online sales. We can also construct the confidence interval. So let's use our example. We had for B1, we'll just plug these values in. We had 0.519 plus or minus. We need that critical value t, the table value, and we want to get the table value from 3 degrees of freedom. And it's going to be a two-sided, we're going to construct a 95 confidence interval. So we'll use that value there, 3.182. So we'll come back, 3.182, that's our value. And then we will plug in the standard error of the estimate for the model, divided by the square root of 4480. Remember that all together is the standard error for the slope coefficient. And you can just leave it in this form. We can just do this. I'm just going to 3.182 multiplied by 4.38, divide by the square root of 4480, and I get 0.208. And then, of course, you can finish this by taking 0.519, subtract 0.208 to get the minimum value. Then you can take 0.519 and add 0.208 to get the maximum value. So you have the range. And we can see that if we do that, we should be consistent with the two-sided confidence interval, or the two-sided hypothesis test. So let's do this. 208, that's going to be equal to 0.311. That's our minimum. And 0.519, let's see, 0.208, 0.727. So you can see that 0 is not within that range. So we would reject the null hypothesis, right? Because there's no 0 in the confidence interval range. And that is consistent with our result here. We reject the null hypothesis and we accept that the slope coefficient does not equal 0, which then we can conclude that the predictor variable x is statistically significant. All right. So in the next video, we will look at how to analyze the computer output.